Welcome to Cloudy with a Chance of Trust, a podcast for digital transformation leaders where we discuss the latest cyber attack issues, enterprise security strategies, and current security events so that you can successfully accelerate network and security transformation. And now, here's what's on our mind this week.
Welcome to Cloudy with a Chance of Trust, a podcast for transformative technology leaders. I'm your guest host for this episode. My name is Sanjit Ganguli. I am a CTO in residence here at Zscaler. And I'm very excited to be joined today by Satish Mohan, who is the former CTO and co-founder of Airgap, now a Zscaler company, and he leads architecture here at Zscaler. Satish is a technology leader with over 20 years of experience building industry-leading cybersecurity, multi-cloud SaaS, and large-scale distributed system products. So today, we're really excited to discuss Airgap's technology, the role of segmentation as it relates to zero trust strategy, and traditional challenges with segmentation, and a whole variety of other topics. So Satish, welcome to the program today.
Thanks, Sanjit. And really excited to be on this podcast with you. Really looking forward to share some of the insights along our journey of building Airgap, and now we're part of Zscaler. So looking forward to this.
Yeah, perfect. Let's talk about the journey. So when I looked at Airgap's technology, even before the acquisition, I just thought it was such a brilliant and simple way to accomplish really an age-old problem. So walk me through the beginning. Let's do the origin story. Every superhero has an origin story. Let's talk about the origin story of Airgap. So walk me through, what were you hoping to accomplish when you got the idea for Airgap? Like, what was missing in the market that you thought Airgap can solve?
Right. Yeah. I mean, that's a great starting point. The idea behind Airgap was really inspired when my co-founder Ritesh, who's also the CEO of Airgap, he was heading the security division at Juniper Networks. So at that time, this is like 5 years back, or during his role, he tried selling Juniper security products to the service provider business. He would meet with some of these large telecom companies, try to sell them Juniper security products, and they would not want to buy any. So surprisingly, that kind of triggered a thought process, and we all sat down, started discussing with each other, why don't they want to buy any network security gear? So that gave us a realization that your mobile operators today are operating on a fundamentally different network architecture than what we see in enterprise environments. So if you look at your cell phone today, like you've never heard of a cell phone being breached due to a malware which was present on your neighbor's cell phone. That's literally unheard of. Like a malware on one cell phone or mobile phone cannot laterally jump across to another cell phone. The reason is your mobile service provider puts every cell phone onto a network of size 1, right? Each cell phone literally lives in its own IP network. So this gave us a realization that, hey, why not do this in enterprise, campus, OT, manufacturing environments? Because they're being plagued by the same problem. Ransomware attacks were on the rise. And then the COVID shutdown happened. So this led us to the thought process that adapting a similar approach in enterprise environments would be a perfect solution to microsegment these environments and kind of like protect them from malware attacks.
So that's absolutely brilliant. I mean, when you made the concept of mobile devices being on a network of one, it just makes perfect sense. And if you look at all the breaches, right? I mean, the once the compromises happen, lateral movement in networks is so easy just because most networks are built to be very, very flat. And so it's hard to do proper segmentation with traditional layer 3 ACLs and VLANs and things like that. So if you can get these devices on a network of one, obviously it solves the problem. But I have to imagine, migrating a mobile technology, which as you can imagine is based on very different architecture to an enterprise IT architecture, must have presented some technical challenges. So walk me through some of the hurdles, like what were you worried you wouldn't be able to solve when trying to adapt that type of architecture into a traditional IT, OT type of architecture?
That's a great question, actually. So when we started Airgap, originally our original architectural solution was not to use a segment of one. We would actually use something called a /30 subnet mask. So if you think back on IP networking, we originally started with a subnet mask being /30, which means that every device has a network of size 4, right? And that conforms very well to traditional IP networking, because if we give it a network of size 4, the device has its own IP address. There is an IP address for the gateway on its network. There is a broadcast address, and then there is a network address itself. So your space of 4 is utilized. So we started going to customers with this approach of like segmenting every device into a subnet of size 4. But then we quickly ran up into a challenge. Because if you're doing IP addresses on a subnet of 4, every IP address needs to be on a boundary of 4, right? This would mean that customers would have to go back and re-IP all their devices, right? Which is a nightmare, especially if you look at enterprise campuses or manufacturing environments. Nobody wants to go in and change IP addresses on anything. And so a lot of these are legacy devices. The reason they were given the IP addresses is lost in time, even amongst customers as well. So midway in the journey of Airgap, we had this brilliant realization, almost saying that why do we need to do a size of 4? Why not shrink it down further? Why not make it a network of size 1, which is as what we call a /32 subnet mask, right? The beauty of this approach is if you start doing a network of size 1, your device's existing IP addresses remain the same. The customer does not have to change any IP addresses. They just insert the Airgap solution, the devices cut over to the Airgap gateway, they still get the same IP address, just the subnet mask changes to /32 or 10. Right. So this is a big technical hurdle which we overcame. And once we overcame this, our customer adoption just took off because it became frictionless for the customers to adopt Airgap.
Yeah, friction is always the enemy of progress, and especially when you have environments with so much technical debt. And as you mentioned, some of these devices have hard-coded IPs for very specific reasons. So, I'm sure that our audience is familiar with NAC and network access control solutions, often agent-based. Horrible. I mean, in terms of implementing and going down this path, very, very tricky type of implementations. Walk me through the environments you were going into and, the challenges that, your prospects were having in doing segmentation in a more traditional manner. Like, what was that environment like? What were those challenges that you were then able to come and provide this very frictionless solution for?
We actually spoke to like hundreds and hundreds of CIOs and CISOs at both in the IT campus sector and in manufacturing OT sector as well. And if you look at all these organizations, everybody almost attempted a segmentation project at some time, but gave up on it, right? And frequently this used to happen when the CISO or the CIO just left and found a new role and moved out of the company and the project got abandoned. But there are actually reasons why this is so. Some of the big challenges are modern IT environments are very complex. There are like multi-layered networks with devices, platforms, applications, and different levels, different tiers in the hierarchy, right? And if you want to go into such an environment and start segmenting them, the first thing you need network visibility. You kind of need to know who's talking to whom, which devices are talking to which applications before you can start adding, as you said, ACLs or policies to kind of say, I will allow this communication, but I'll not allow that communication. You kind of need to know what you want to enforce. Otherwise, you end up breaking existing applications. It's actually a big hurdle. And this is one of the primary reasons we have seen why segmentation projects don't take off in IT organizations. People are just scared to segment further and disrupt legacy applications. And also, if you were to take like an agent-based approach and try to segment, like how the traditional industry has approached network segmentation is by deploying agents on every endpoint and then microsegmenting using those agents. But as you know, it's kind of widely known the problems agents cause. Like it breaks compatibility with legacy operating systems. Some of our manufacturing customers are actually running operating systems as old as Windows 95. Believe it or not. So they're very scared to install anything on them, let alone deploy a vendor's agent on it. So our Airgap approach makes microsegmentation super easy. We are a DHCP proxy in between. We just insert into the network. Customers don't have to change anything on their endpoints or devices. As the devices refresh or renew their DHCP leases, since Airgap is a DHCP proxy, Airgap now starts responding back to them with the same IP address, but except that we rewrite the DHCP response to insert a subnet mask of /32 on it. What happens is when we go insert Airgap into a customer environment, over a period of 24 hours, we see that devices gradually migrate and cut over to Airgap in a very seamless manner. So there's no disruption to existing network traffic. And all traffic within 24 hours or whatever your DHCP renewal interval is, you'd see that the entire environment gets microsegmented.
Perfect. Yeah, and for those maybe not as familiar with DHCP, let's maybe back up a little bit and talk about dynamic host configuration protocol, or DHCP, which is what assigns the address. So Satish, walk us through. I mean, you kind of gave a high level, but walk us through kind of a deployment of an Airgap solution, right? So you deploy the DHCP proxy. The device, once it asks for an address, gets a new subnet mask. But walk us through exactly how that's assigned and then the steps by which then the Airgap server then does to process and provide the layer of microsegmentation.
So when we go into a customer and deploy the Airgap gateway, so the Airgap gateway is like, it could be a virtual appliance or a physical appliance. So this is typically located on your layer 3 switch. We recommend our customers to actually put Airgap on a trunk VLAN. So if you're familiar with trunk VLANs in layer 2 switches, it's a port on the network switch where multiple VLANs are trunked to it. So that way Airgap can take over the function of being a gateway for all these VLANs. So the first thing the customer does when they onboard a particular VLAN onto Airgap is they shut down the SVI interface or the switch virtual interface on the switch. Like it could be a Cisco or a Juniper Arista switch. You shut it down. You assign the same IP address to the VLAN on the Airgap gateway. So Airgap gateway instantly takes over the functionality of being the default router or the default gateway for that particular VLAN. And the next step is Airgap gateway actually serves as a DHCP proxy within this environment. So we tell customers that you don't have to change your DHCP server. DHCP server is very sacrosanct to customers because it actually manages the IP addresses. It's a very closely guarded, protected piece of software in the environment. So we don't make any changes to the DHCP server. We just configure Airgap to be a DHCP proxy pointing to the existing DHCP server. So now let's delve a little deeper into the DHCP protocol itself. Let's say you have an endpoint in one of these VLANs. The first thing when it needs an IP address or when it wants to refresh or renew its IP address, the first thing it's going to do is it starts out by sending something called a DHCP discover message, which is a broadcast message sent to the switch. Basically, hey, asking the switch, hey, send it to everybody. Let me know if there are any DHCP servers out there. Since Airgap has been configured as a DHCP proxy, we are actually listening to these kind of broadcast messages. We actually pick up this message. We, of course, relay it to your enterprise DHCP server, but we keep track of which server has been assigned for this device. So now what happens? Your enterprise DHCP server is going to respond back to this device with the IP address. Because Airgap being a proxy in between, it's in line to the DHCP server. It intercepts this response, which is typically called a DHCP ACK packet, coming back to the device. We intercept the packet. We rewrite the subnet mask on the response, right? We change it like you could be sitting on a /24 network. We change it to a /32 network and send it back to the device. From the device's point of view, it doesn't know that this rewrite has happened. It's transparent to it. It just sees that, hey, I got an IP address, which could be the same as my previous IP address, but my subnet mask changed to /32. Now here's the interesting thing. So what happens when you're a device and you get a subnet mask of /32, what happens is basic IP networking tells you that even if you want to laterally communicate to another device in the same VLAN, you're in a network of size 1. There is no device in your network. You have to send it to the gateway. That is basically what your RFC 791, your good old IP RFC tells you that actually. So the device confirms to that, it will send the packet back to Airgap. Right, for any kind of lateral communication, even legitimate communication, or even if a device were to be compromised, a malware on it, the only way it can discover and talk to other devices is by going through Airgap. So this now makes Airgap an ideal enforcement point to microsegment a device, only allow authorized flows between the devices and shut down anything which is not authorized, alert the operator. We do all those things.
That's beautiful, right? That architecture is just so beautiful because it comes through the server and then you have the visibility. But walk me through now, how do you actually come up with enforcement policies? So let's take an example, a traditional example of trying to create a segmented IoT, OT /IT network, right? You want to create that segmentation. How would someone listening, how would they create proper enforcement points to ensure that east-west traffic doesn't occur between and keep segmentation between those separate networks?
Actually, you asked a very relevant question. When you start a microsegmentation project, you typically don't have visibility on which systems in your IT network are talking to which endpoints or controllers, PLCs, sensors in your OT environment. So there is this bridge between IT and OT. So the way our customers typically start their segmentation journey is to first do a coarse segmentation of IT versus OT. So IT is usually in a different VLAN and OT is in a different VLAN, right? So you typically separate IT and OT. So then the second level of microsegmentation really involves on pinpointing the exact traffic flows of which IT systems are talking to specific OT systems and enforce policies to allow or deny them, right? So, but before you can do this, you need to do two things. You need visibility of the existing network traffic. You kind of need to do some kind of device discovery, kind of figure out what are my attributes, what is the characteristic of this OT system? Is it like a PLC? Is it a sensor? Or in some of our customers, we are in the healthcare sector. We work with hospitals. So some of these healthcare devices talk like there's a specific protocol called HL7. So there are very specific protocols they talk on. So since Airgap is a gateway, inline gateway, sitting kind of bridging this IT, OT, VLANs, all the traffic is flowing through Airgap. We're literally like an east-west firewall in that sense. Everything goes to Airgap. So we never look at the contents of any traffic data. We only look at the packet headers. So from the packet headers, we actually gain a sense of certain metadata attributes about the protocol and the devices being communicated. Right? All this is fed to our data lake in the Airgap cloud, sitting in the cloud, right? Where we actually correlate all this information, provide like both like a network flow view and like a graph-based traffic chart, saying that which endpoints and which control systems are talking to each other, and come up with a recommended set of policies saying, hey, these are the flows which you need to allow because these are being used by your IT, IoT, and OT devices. And these seem extraneous. We actually recommend that you actually block that kind of thing. So that actually helps our customers to start enforcing policies. So there is, I would say, like a 30-day period where we deploy Airgap. Customer just uses Airgap to kind of learn about their own environment. And then we work very closely with the customer during this phase, our field support folks as well. We actually come up with a recommendation to the customer saying, based on what we observed in your environment, this is what we recommend. This is how you need to microsegment your environment.
So, Satish, walk me through. So, as now that you're on the Zscaler family, Zscaler traditionally have been very focused on user to app segmentation. More recently, workload to workload segmentation. But this gets Zscaler into a whole new world of device segmentation, branch segmentation. So to talk me through how does what Airgap's doing, how does that fit into the broader kind of zero trust platform, the Zscaler platform, if you will? And how does it complement the other things that Zscaler traditionally were doing?
That's a great point. I mean, I'm like really super excited about this acquisition by Zscaler because to me personally, Zscaler plus Airgap is a perfect marriage in some sense, right? Because Zscaler has been traditionally focused on zero trust, and as you rightly mentioned, user to application zero trust, app to app zero trust segmentation. Where Airgap kind of complements this is Airgap provides you like this east-west security. So the way I see it is Airgap provides you east-west security and Zscaler provides you the north-south security. There's a lot of synergy here and each complements each other. And with Airgap, what we bring in is we bring in this rich experience of actually deploying in OT, manufacturing, critical sector environments. We have a lot of device discovery feature, device fingerprinting built into our product itself. Within Zscaler, we're now exploring how we can leverage the device fingerprinting information which Airgap is collecting and use it in some of the threat detection products, the AI recommendation products, which Zscaler already has in the family of products.
No, that's great. And frankly, when I heard the announcement, it made perfect sense how this fills the east-west gap in our solution. And now we have a very holistic segmentation story. So it's wonderful that Airgap is now under the Zscaler family. So Satish, we're pretty much out of time. Any final comments you'd like to make before we end the podcast today?
This was really awesome speaking with you. Really excited to be part of Zscaler family out here. Looking forward to collaborating and expanding our reach with the existing products into Zscaler.
Yeah, that's perfect. So thanks, everyone. This was the end of the Cloudy with a Chance of Trust. And thanks, everyone, for listening.
Thanks for listening to Cloudy with a Chance of Trust. Check back with your podcast provider regularly for more episodes. Statements by Zscaler podcasters and guests are informational only and should never be construed as legal advice. You should consult with your legal advisor on matters related to you or your business. Zscaler makes no warranties, express, implied, or statutory as to the content of this podcast, and it is provided as is. Content on this podcast may contain forward-looking statements that are current as of the date of recording and subject to change. These statements are subject to the safe harbor provisions created by the Private Securities Litigation Reform Act of 1995. Full legal disclaimers are available at revolutionaries.zscaler.com. Copyright 2022.